Deep Learning by Yoshua Bengio is a highly detailed exploration of the deep learning field, written by one of the leading figures in AI research. While the textbook Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Corville provides a comprehensive, multi-author perspective, Bengio's own work on deep learning is pivotal in understanding both the theoretical and practical aspects of neural networks and their applications. In his contributions to the field, Bengio has focused on the development of algorithms that allow computers to learn complex representations of data, enabling remarkable advances in various domains such as natural language processing, speech recognition, and computer vision. In Deep Learning, he elaborates on the mathematical foundations, innovations, challenges, and future potential of this transformative technology. The core idea of deep learning revolves around teaching machines to learn patterns directly from data, without the need for manual feature extraction. This is done by training neural networks with multiple layers of processing units, often referred to as deep neural networks, DNNs. Bengio begins by outlining the history of neural networks and their evolution from simple models like the perceptron to more sophisticated systems that can learn hierarchical, abstract representations. These networks consist of layers of neurons, with each layer transforming the input data before passing it on to the next layer. In deep learning, the number of layers is deep enough to enable the model to learn very high-level abstractions of the data, which traditional machine learning methods struggle to achieve. Bengio emphasizes the importance of unsupervised learning in the deep learning paradigm. Unlike traditional supervised learning, which requires labeled data, unsupervised learning aims to learn patterns in data without explicit supervision. Bengio has contributed significantly to the development of unsupervised learning techniques, such as deep belief networks, DBNs, and autoencoders, which allow models to learn a compact representation of input data without needing direct labels. Unsupervised learning is particularly useful in situations where obtaining labeled data is expensive or impractical, making it an essential component of deep learning models used in many real-world applications. The book covers the mathematical foundations of deep learning, such as gradient-based optimization techniques and backpropagation, which are central to training neural networks. Backpropagation allows the network to adjust its weights based on the error of the output, enabling it to learn from mistakes and gradually improve its performance. Bengio provides an in-depth explanation of how gradient descent is applied to optimize the parameters of deep networks, along with the challenges associated with training deep architectures, such as vanishing and exploding gradients, which can prevent networks from learning effectively. Another key area of focus in Bengio's book is representation learning, which is the ability of a model to automatically discover the structure of data without being explicitly told what features to focus on. Deep learning models are particularly good at learning representations because of their ability to learn from raw data in an unsupervised manner. Bengio has argued that deep learning algorithms, by learning data representations hierarchically, are able to uncover intricate structures that may not be immediately apparent to human designers. This ability to learn hierarchical features makes deep learning models more flexible and powerful compared to traditional machine learning methods. Bengio also addresses the various challenges in training deep neural networks. One of the significant difficulties is ensuring that the model does not overfit to the training data. Overfitting occurs when a model learns not only the underlying patterns in the data but also the noise, leading to poor generalization to new data. To mitigate this, Bengio explores regularization techniques such as dropout, which randomly drops units from the network during training to prevent overfitting. Additionally, he discusses the importance of transfer learning, where pre-trained models are fine-tuned on new, related tasks to achieve high performance with less data. The book devotes considerable attention to convolutional neural networks, CNNs, which are particularly effective for image processing tasks. CNNs have been widely used in computer vision for tasks like image classification, object detection, and segmentation. The key innovation behind CNNs is the use of convolutional layers, which apply filters to local regions of an image to detect features like edges, textures, and patterns. By stacking multiple convolutional layers, CNNs can learn complex representations that are invariant to translation, rotation, and scaling, making them incredibly powerful for visual recognition tasks. Recurrent neural networks, RNNs, are another important topic that Benjo addresses in depth. RNNs are designed to handle sequential data, making them ideal for tasks such as speech recognition, language modeling, and machine translation. Unlike traditional neural networks, which assume that inputs are independent of each other, RNNs have the ability to retain information about previous inputs, allowing them to model temporal dependencies. Benjo discusses the challenges associated with training RNNs, such as the vanishing gradient problem, and how more advanced versions, like long short-term memory, LSTM, networks and gated recurrent units, GRUs, have been developed to overcome these limitations. Benjo also discusses the ethical implications of deep learning. As deep learning models become more powerful and widely used, they present both opportunities and risks. One of the concerns Benjo addresses is the potential for deep learning algorithms to perpetuate or amplify biases present in the data used to train them. For example, if a model is trained on biased data, it may learn discriminatory patterns that affect its predictions, such as in hiring algorithms or facial recognition systems. Benjo highlights the need for transparency and fairness in AI models and stresses the importance of developing methods to detect and mitigate biases in machine learning systems. Furthermore, the book explores the potential applications and future directions of deep learning. One of the key contributions of deep learning has been its ability to achieve human-level performance in certain tasks, such as beating world champions in games like Go and chess. Benjo highlights some of the most exciting applications of deep learning, including autonomous vehicles, healthcare, e.g., diagnosis from medical images, and natural language processing, e.g., machine translation and sentiment analysis. However, Benjo is also cautious about the implications of deep learning as it becomes more pervasive in society. He recognizes that while deep learning can solve complex problems, it is not without its risks, including the potential for misuse in areas such as surveillance, security, and warfare. The book concludes by discussing the future of deep learning and the open research questions that remain. Benjo emphasizes that deep learning is still an evolving field, with much more to be discovered. For instance, while deep learning has made incredible progress, it still lacks true generalization abilities, meaning it struggles to perform well outside the specific tasks for which it has been trained. Benjo suggests that the next frontier of deep learning will involve the development of models that can reason, understand context, and generalize from limited data, traits that are still elusive for current models. Overall, Deep Learning by Yoshua Benjo is an essential resource for anyone interested in understanding the intricacies of deep learning. It provides a solid foundation in the theory behind deep neural networks while also covering practical techniques and applications. Benjo's expertise and deep insights into the challenges and future possibilities of deep learning make this book a definitive guide to one of the most exciting areas of AI research and development. Through a combination of rigorous explanations, practical insights, and thoughtful reflections on the broader impact of AI, the book offers both a comprehensive technical overview and a vision for the future of intelligent systems.